Hello, everyone. How are you? ¿Cómo están? It's a pleasure to be again with you here and to be along with my colleague, Ismael Valenzuela, and to present together this part, Threat Hunting 101, YARA and Jupyter notebooks for threat hunting. How are you, Ismael?
Good, very good. Glad to be here with you again.
Thank you. Yes, and same for me. And also sharing this experience, especially based on, the cyber attacks we are facing today. We see new vulnerabilities against Exchange servers, and every day something new coming. So sometimes it's really challenging actually to hunt effectively. Like to find those new implants, new techniques, and especially if you have great amounts of data, just terabytes of files, or like your traffic net flow is so big, it's like you have everything but you don't see anything. I don't know. Is that something you have seen when working with the customers? Does it sound familiar to you?
Oh yeah, absolutely. I mean, a lot of the hunting techniques that we're going to be explaining here, they're not really super new, but it's all about having the right tool set, right? And sometimes when you're dealing with a lot of data, one of my favorite techniques is what we call divide and conquer, right? Or sampling, which is start with something small and try to find out what data you have, explore a little bit, and then you can find out other clues and other threads that you can pull that will be helpful in your investigation. So that's what we're going to be discussing. I've successfully implemented some of these techniques in the past, working with very large environments, and this is similar to what we do internally in the team. So we're going to share some of the tool sets that we just use on a regular basis, right? To do threat hunting for our customers, to identify new campaigns, new threat actors.
Yes, indeed. And we would like to invite you all who are attending this webinar with us to also send us your questions. Feel free to do so. We're here to read them and also to answer them, hopefully. But before we start, probably Yara is it something like everybody knows, at least like heard about that. But honestly speaking, when I think about threat hunting and Jupyter notebooks, I'm a little bit like, how can I use it? Like, and what domain and what is the use case for that? Um,
Right.
what can you tell us?
Well, think about Jupyter Notebooks as an interactive type of a web application where you can put your Python code in there and use the same libraries that you would use with Python to check, hashes against VirusTotal, or to import, I don't know, the PE libraries to do manipulation, or finding interesting things in the PE headers, or any other type of. We know that there's so many, thousands and thousands of libraries and applications that you can use for cybersecurity purposes with Python. Same things that you would be able to do with a Python script, but you can do that in an interactive way, in a sort of a web application where you can just write snippets of code, blocks of code, and then massage the data, look at the data, explore it, create like graphics, right? To understand what you're looking at, and interact with something that it's very useful, which is like a type of a spreadsheet that you can use in a programmatical way. I'm talking about pandas data frames. I know it may
Mhm.
sound like something new to you, but a pandas data frame is just like an Excel spreadsheet, a matrix with rows and columns, but you have that in memory, and then you can go and iterate over each of these elements and do additions, do substitutions, duplicate things or remove duplicates, and interact with that algorithmic structure, and then create graphics based on that. The beautiful thing about it is that you can do that with code, and with some simple lines you can do a lot of powerful things. um,
Mm.
so why don't we just go through some examples? Maybe
Why
that's the
not?
best way of
Yeah.
showing that, right?
Hmm. Hmm.
So let me share my screen here, and as you said, feel free to share your comments. If I'm looking at different screens here, it's like because I'm looking at Twitter, I'm looking at the comments here on LinkedIn. That way we make it more fun, right?
Hmm.
Let me just share my screen. All right. So hopefully, Uh, Dmitry, if you can confirm that you can see my screen now. Yep,
Yeah, we can see it.
perfect. So all of this code is on my GitHub, github.com / about security. And some of these snippets of code I have shown in other webinars that I've done in the past, but I every now and then I update them. Today I'm going to show something extra that I haven't shown earlier. Again, it's not rocket science. It's just little things that can maybe trigger your imagination, and you can use this for other things, right? But this is useful in the context of hunting. I remember one of these scripts I was asking on. I spent like a Sunday morning doing hunting on DNS logs, and I was tweeting this like, "Hey, would this be useful to anybody if I share this code?" And everybody was like, "Yeah, yeah, share it." So that's what I'm gonna do right now. I'm gonna share it with
Oh,
everybody. It's actually on my GitHub right now.
oh
So
yeah. So are you saying that you're gonna publish that on your GitHub and we can just go and download it? Like it's
it's
available for everybody?
it's already there, and I will
Oh, wow.
I will show you because I was uploading the code like 5 minutes before this because that's what we do, right? We just do stuff like 5 minutes before the hour. But yeah, it's here. I'm gonna explain what this is: Titanic, PCAPs, DNS analysis, packet analysis. There's a bunch of things for you to explore, and I have plenty of references to blogs and tutorials. A lot of this is based on other things that I have learned from other people, so I like to use those references as well. And if you want to learn more about data exploration, I highly encourage you that you follow these data science tutorials. Very useful. Uh, this is a simple Jupyter notebook that, as you can see, I'm using this with Visual Studio Code, something you can download for free. And you're going to need certain libraries. Of course, you're going to need Python. Uh, I recommend that you check Anaconda. Anaconda is a software package that includes all of these different things: the Python, the Jupyter notebooks. It includes the Matplotlib and a bunch of other libraries that you're going to use for plotting the data and showing some of these graphics. I like to play with code and get my hands dirty to learn something. So I found this tutorial very useful, and it's a tutorial that leverages the data set available from the passengers of the Titanic, right?
Hmm.
And it's very interesting. You can download this CSV file from Vanderbilt University's Department of Biostatistics, and you don't have to do that. I already give you the code to do it. It's already in here. But I import some libraries. Notice how there's some blocks of code, right? So I
Hmm.
can individually execute. All of these are comments, so there's nothing to execute here. But I can individually execute this code, and it imported pandas as PD. This is just standard Python. NumPy, libraries that we're going to be using to manipulate the data. And then finally, I load the CSV information that I downloaded from that website, that university, and I load it into this pandas data frame. That's PD, right?
Hmm.
So now we can just play with this. Took like zero point 0.4 seconds to load the data. And now we can just look at the data here. I can even do something. Well, let me add a piece of code. What can go wrong, right? We're just going to write things as we go.
Let's do it. It's a live demo, real life.
That's the fun piece of this. And okay, so if I print the data, you can see what we have in this CSV file. I'm just seeing a output that is truncated. It's not showing me everything, but I can see that there is columns. Again, think about this as a spreadsheet, and it may not be the best way of looking at the data here, but we know that we have 1,300 rows and 14 columns. So it's a matrix, right? And we can programmatically now look at columns, look at rows, and do operations with these values, statistical analysis, and things like that. Now, this is useful to, as I'm saying, explore the data. But the data must fit within the memory of your computer. So if you're looking at exploring terabytes and terabytes of data with this is not the tool for that. Okay. This would be a tool to explore a subset of that data. however, as much as it can fit within your RAM, your memory, or the memory of your device, explore it, and then extrapolate that to some other type of big data platforms, or data lakes or things like that. But um, this is something that needs to operate with some limited information. But still, we're going to operate with data sets that have many thousands records, hundreds of thousands of records in some cases.
And how can you use it? Let's say this statistical approach, like it's very useful. I see when you want to find really the answer for something. But when we think about threat hunting,
Hmm.
right? And for example, we have a certain amount of network traffic, and it's super hard sometimes actually to find what's going on, like what is wrong. I know, like, most of the traffic is usually clean traffic and there's nothing interesting, but how to find those goodies inside of
Right.
tons of pickups?
There's not one single answer for that, but let me show you. I'm gonna leave this Titanic sample here for you to play with, and you're gonna see that, for example, it's very easy to just get information about the passengers, the age of these passengers, which ones survived, which ones didn't. Very interesting. Like, you can see some graphics here on the survival rate based on the fare of the ticket they bought.
Hmm.
And not surprisingly, you're going to see that those that bought a more expensive ticket, they had a higher rate of survival, right? But it's more about learning how to manipulate data, and to plot the data. Why is this useful for hunting? As you said, many different applications. I'm going to show two. One with logs, DNS logs, another one with pickup data. This Jupyter notebook that you have available on my GitHub repo has a function that ingests a pcap, and it transforms it, or it puts it into a data frame, into a pandas data frame. So now you can manipulate the pcap, you can explore the pcap and look at all the information in that particular way. This is based on a webinar that I did with a buddy of mine, Doug McKee, and we did that for SANS. I think it was last year on a Purple Teaming Summit, and we showed this. So there's a YouTube video with step by step. I'm not going to go through all of that, but if you go to YouTube, you can find it there. Also, my GitHub, I reference this. But in this case, I'm looking at pcap traffic in 4 different pcap files. I put each of these into different data frames, and then I start just looking at simple statistical information. For example, how much UDP traffic we have versus TCP traffic. Protocol 17 is UDP, Protocol 6 TCP. What else? What are the IPs that are sending payloads or sending data? Well, 7140 is sending data, more data, and which IP addresses are receiving more data? 135. So it looks like we have a conversation between these two different IPs. By the way, nothing that we could not see with Wireshark, right? At
Hmm.
least to this point. But then we will
Right.
see how we can go beyond what Wireshark can do. Statistical information about ports, protocols. Let me go into something a bit more interesting, like plotting the length of the payloads for the TCP traffic, for the UDP traffic. And I'll tell you something, this traffic is actually very interesting because it's from a proprietary protocol. I'm pretty sure you've found proprietary protocols, in your career, right, Dima?
Yeah. Yeah. Hmm.
Malware in many cases, right? Malware
Hmm.
authors, not always, but sometimes they may just create their own protocols. And if it's not known by Wireshark, you're going to load it into Wireshark, and what's going to happen? Wireshark
That
doesn't
you
know what it is.
hmm you can't interpret it. Hmm.
So it's just going to show like a bunch of hexadecimal to you. And now you have to manually understand, try to figure out what's the header, is it variable length, is it fixed length, what goes after that, where does the payload start? This is where it can be very useful to apply this code to programmatically slice and dice these packets. In this case, I slice and dice the payload to find out patterns, and it shows how there's a pattern that repeats, some hexadecimal patterns that repeat across the payloads. These are octets. right? 4 octets that represent an IP address. So that's how we decode it. And once we go through that, we find that there's also some geo coordinates inside of these packets. And look at this. This is my favorite section. When you plot this PCAP traffic, the 4 PCAPs, and you plot the TCP and UDP packets over a time series,
Hmm.
what do you see here?
It's not knocking on the door. Then, then, like,
TCP, 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 bang, UDP. TCP,
mhm.
TCP, bang, UDP. And what else do you see here? This is like a pattern, right?
Yeah, actually, those visualizations just so great because you can easily spot there is a communication, right, with the C2. It's like reporting to the C2
Exactly.
heartbeat.
And in this case, this is a proprietary protocol that it's kind of typical from industrial environments, OT environments. So you have the TCP packets, and the UDP packet carries something different. It's a beacon, right? And
Mhm.
that beacon in this particular case contains, how cool is this? I can print the packets in hexadecimal. Look at the hex and also the ASCII representation.
Mhm. Mhm.
What do you see in here in the ASCII piece?
Data.
41 dot. It's data, right? But what type of data do you think this is?
But it can be victims information, reporting like I'm here, I'm still alive, and this is my configuration.
Right? And
Mhm.
let's ask the audience. Let's see if somebody can tell me what this is. I mean, it's only one Google search away. All you have to do. This is how I do it. I don't know, Dima. Let's demystify this. I'm not, as smart as other people. So what I do is just whenever I don't understand something, I just copy it and I put it on the
Checking.
table.
Maybe someone from audience can also Google it for us.
Yes, 41.40338, comma 2.17403. Come on, guys. I'll give you 5 seconds. Otherwise, I'll let you know what this is.
IP.
IP
Uh,
address.
yes.
Close, but no. Harry says geocoordinate. Yes, geocoordinates. You got it. Exactly. Geocoordinates. And all we have to do is longitude and latitude, right? Exactly. Is to extract that out of the payload and bang, plot it. So that's the code you have here. This code uses a library called Folium, and it just plots these geocoordinates on a map. So again, this is typical from industrial protocols. Things you're going to see is maybe traffic lights doing this type of stuff. It's really really interesting. So that could be a way in which you understand something that you don't know. Here's another final example, and this is the last Jupyter notebook that I uploaded, like literally 15 minutes ago or 20 minutes ago. It reads an output, or sorry, in this case, a CSV file. Yeah, the output of the Windows DNS analytical logs. So if you want to know your DNS traffic, you go to your domain controllers that have the role of a DNS server, right, on Windows, and you want to enable DNS analytical logging. This will log to the native Windows event logs, and it's a comma separated value type of file, with columns saying this is the resolver, this is the IP address of the client doing the resolution. This is the domain. Is it single A or quad A if it's IPv6, and then all of the different IPs that it resolves to. So this is what I'm doing here. I'm going to show you this tactic that is very, very simple. Imagine that you're trying to find odd things based on your DNS traffic. That's one of my favorite techniques for hunting. Give me DNS. But as in this case, well, this is a small file, but it has, I can print the data here. Let me add some code. Print data. And you can see that the resolver, it's my domain controller, tyrellcorporation.us. Let's see, what do we have on that website? So it's one of the machines that I use for training purposes. And some lookups, right? And these lookups are going to some interesting domains. That's what it's in the CSV file. But now, how many rows do I have in here? If I click on data describe, it will say that I have 22,000 records. Now, going and doing enrichment of 22,000 records is a lot, right? It's going to do a lot of API lookups, and I may consume all my quota with VirusTotal or things like that. So what I'm going to be doing is reducing this data by taking everything out that is in the list of the Cisco umbrella top 1 million file. Here's why, because I want to look at the outliers. That's a
Mhm.
common hunting technique, right? It doesn't mean that you cannot find evil things in the top 1 million list, but I don't want to know, I don't want to see the traffic going to Google, to Amazon, to Microsoft. I just want to see the things that might be interesting, odd. Doesn't mean it's malicious. It means maybe there's something suspicious in there. So that's what I do. I download the top Cisco Umbrella 1 million file from their cloud, from the Amazon cloud. I read this. I put this into a Pandas data frame, and this is the beauty of this. Look at it. With one single command, I can say put into the reduce variable or data frame all the data that is in my list that is not in the Cisco 1 million list, right? So now with that simple command, I exclude all of these domains, and now I have 3963 records. So I have reduced that by a lot.
Right.
What can I do next? Well, I can reduce the duplicates, and I have 200 records. So I started with 29,000 or 22,000. Now I have 200 records. That's a lot more manageable. Because
Absolutely.
remember, you're just trying to find out the like the outlier, right? Something weird. And now I use the same technique. I'm going to plot this. I'm going to use an API that this is free. It's ipapi.com, but you have some limitations, obviously. So I'm just going to do this with 10 of the first records. As I go through this code, it's going to resolve the geo coordinates for these domains, and I'm going to plot them into a map. And now what I can do is to find out who's doing this. So my domain controller, right, is doing this type of traffic, which is interesting. I have also traffic going to Brazil.
Oh, this is a rat for sure. Yeah.
I think you know one or two things about Brazil, right? You
Yeah.
know,
Exactly. So it's like,
Portugal. Now, again, this doesn't have to be necessarily malicious. Let me share a secret with you. This is Emotet traffic. This is Emotet traffic that has recently been downloaded Cobalt Strike beacons. And if you guys follow us, and you know that we wrote a book, right, on finding beacons in the dark, on Cobalt Strike beacons. This is something that we regularly do to find out these beacons. Maybe in a later episode we can share more details on how we do that. This is another domain that has been serving Emotet that would result later on into downloading a Cobalt Strike beacon. So again, nothing. I don't think this is rocket science, but it's little techniques that can help.
yeah, absolutely. It's very interesting. And it seems like for me, at least, that domain controller, it had several infections, Emotet, and seriously, that rat from Brazil, it's just there. Someone
Well,
was there.
is that the domain controller, or is it the client that is resolving through the domain controller? That's what
Hmm.
now the next what we need to find out. Most likely it's just a client that is resolving right through the domain controller.
Hmm.
But this is a technique that I've personally used when doing incident response for many years, or just doing threat hunting, to find out those little things, those little threads that you can pull to uncover something you didn't know about.
Yeah, thank you. Yeah, very much. And also thank you for your comments because we are reading them here. And Bob, what's up, everyone? Yeah, pretty good here. Having nice conversations. Yeah, welcome. Thank you for being with us.
Now, Dima, I have used YARA myself, right, over the years. In fact, I wrote a tool called Rastreador which most people couldn't pronounce in English because I thought it was obvious that everybody knows what rastreador is. But I wrote this little tool with Python that helped me when I was doing instant response at scale. This was before EDR times, to do hunting at scale on large networks with over 100,000 machines. And I would use YARA rules to scan memory, to scan the disk, and then get results through a RESTful API. But I'm not, with you here in the room, I'm not going to say that I'm an expert on YARA at all, because I know maybe very few people, or maybe no one, that knows more about YARA than you know. So since we have you here, tell us a little bit more about how you use YARA for hunting. What are some of the tips that you want to share with the audience today?
Yeah, it's very interesting that many people today, even like I would like say probably most, they still think that Yara it's mostly like for string searches,
Mhm.
right? Oh, if you have like interesting strings, you can just put them in a rule and to start hunting. If you don't have strings, there's nothing to do, no Yara for you. Well, that is not actually about Yara. Yara, I would like to say a couple of words first. It's a great tool. It was originally developed and maintained still by Victor Manuel Alvarez, who's in Spain, and that tool is under continuous development and owned by Total today. So. Uh, when they think about threat hunting or we think about YARA and threat hunting, here's the tip first. Split your rules in different data rules, let's say like set of rules. Because some go through frustrations when they write a YARA rule and then it gives like false positives. They think, oh, YARA is bad or YARA is hard, and then they just drop using it. Others think it's like the rules are so strict, you can detect things. So basically, the first idea, is to have two or more different sets of Yara. For instance, one is for hunting. That means you may write even like dirty Yara rules where you accept certain level of false positives because your purpose is to find those files, to find those objects on disk which are suspicious for you. You assume they are malicious or can be potentially malicious based on whatever criteria. I don't timestamp, language, hash, obfuscation, and so on and so on. Another set of rules which you should have, it's like curated rules, basically tested rules, which are not necessary for hunting but for regular scans and detections, yeah, detections of those campaigns and of already known threat actors. So you are trying to keep your system up on top and eventually detect new samples by the same threat actor, but those rules are tested for false positives and it's confirmed zero false positive, and at the same time they're good enough to detect more samples. So that is like a general approach, and then the sky is the limit. Basically you can start writing rules for whatever you want. This is the big advantage. You can run Yara in the memory on disk. You can put it even like to use Yara against your network traffic or for incoming emails. So there is no limitation. You can use it out for incident responding when you're also hunting for specific artifacts you have recovered, I don't know, from the memory or from other procedures. So it's great. Basically, you can use it whatever you want, even to find a lost document. Let's say you have a document and you can't find it because, or your disk broke and now all the names are generic, but you remember like certain characteristics of the file, and like all the files are just in one same folder. So based on that, you can write the YARA rule, which will find that specific file in terabytes of information of a broken disk or uh, if like your circumstances are
Wow.
different.
So in summary, you put Yara in your sandwich, right? It's going to be awesome. It's going to make it a
Absolutely.
lot more flavorful.
Yes, indeed, indeed.
Do you have some examples to show us?
Yeah. We prepared something like specifically for this. Let me, I think I'm gonna share my screen. in just a second, and it's here. So let's imagine the following scenario. You have read about a campaign which is targeting the industry you work in. And unfortunately, there are no YARA rules for that. And you don't know if your endpoint detects it or not, because the sample mentioned in the blog post is not available anywhere. So you ask to the friends, they don't have it. VirusTotal doesn't have it. You email to the company which published the research, and they say, sorry, we can't share the samples. And you're sitting there and you're thinking, like, crunching the numbers, what can I do? How can I know if my machines, like my network, any of them has that sample? So easy. Basically, you can write the YARA rule with the hash, right? For that, you just need to import the hash module for YARA, and you define in your condition type of the file. This is important. In this case, it's an image. And then your file size. Usually that information is already provided in the blog post. You already know it's a public paper. So you see like, oh, the file size is this is an executable file, and then the hash is there. So if you write the rule like this and you run it in your network, you will find like if find out if you have that files like malicious file or not in any of your systems. So same is true. Let's say someone is stealing documents from the company, and you're trying to find out who is doing that. Someone is copying those documents and maliciously changing the file name and extension, and simple searches, I don't know, like through like all that software inventories and such, they just don't work, right? Because you search for the original file name and there is no result for that, but you know the file size, and you know the type of the file, and you know the hash because you can hash that sample. Again, you can write that rule based on those characteristics of the files, and to find out who is having those files and where. So like, where is that private collection? I want to know it. So you
Mm.
run that rule, and you will find it again. Same for any other purposes. So here is this example is about how to write the YARA rules based on hash. And in this case, it's MD5, but it can be also any other algorithm. What about timestamps? Let's say you know that it's unusual to have files on your disk, on your system, which are super old, or like with a future timestamp, or even more. You're suspecting that there is an incident. Like, we know that something happened to our, we got breached, but we don't have like an exact time. We just know it happened, let's say, between February 23rd and February 25 of 2018, and probably we suspect that those artifacts might be still in the system. By the way, those dates are like very old, of course, but you can just change them. Same. So basically, when we think about an intrusion, um, let's say it might be like a portable executable file, like in this case, an executable file. But if it's a PowerShell or any other thing used, like you can just change this condition, or just to delete even like condition for the file type. But still, if you keep the file size, it will help you also to speed up the process, especially when you're just scanning like huge amounts of data. And then this is the thing, like in your condition, you just define PE timestamp. And this is there for the files, for the executable files, and you provide this time in Unix time, because Yara don't um, use our clocks, right? Like the way we count hours and minutes. So you need to use the Unix
Epoch time,
times.
right?
Yeah. And then that's it. So you just run, and it will show you all the files in your system which were compiled, or they have the compilation timestamp between these dates. This is another also example for the threat hunting. Another one, let's say you are a business, I don't know, you're operating in the United States, UK, any country, Spain, you're in Africa, whatever. But there is no reason under the sun to have any files in your systems which were compiled using Russian language, Chinese language, North Korean language, and so on. Like for you, it's not anything good to find those files, special, say like North Korean samples. You think like, ooh, how? Like, I mean, it's I don't need those samples, and if I have them, it's suspicious. So, again, so what you can do, just to write a rule based on that. So here in the condition, you also provide PE locale, and then the language, the code, the language code. Those codes are available on the Microsoft MSDN website, so you can also search for them, and that is how you can define. And it's very interesting. It's very specific. It's not like generic. Let's say, oh, Spanish language. Microsoft even provides like, oh, this is Spanish from Argentina, this is from Spain, this is from Ecuador, Mexico, and so on. So that is how you can also find for suspicious files in your system, which are like, how come I have like executable files with a Russian language? Like, I mean, I don't have anything like any Russian software in my system. That can be also very interesting for you, even like for just to understand like what are your applications made of. Because sometimes you have like an app or a system, it's like a huge bundle, you install it and brought like 1000 files, but probably some of those components are also like, been outsourced, adopted from other projects. And that is how you may find out that in your system, you may find, oh, wow, I have those files executed, files which can be executed. And they come originally from those compilations. So it's interesting. And finally, obfuscation. Obfuscation is also very interesting because it's mostly used eventually, not only but like mostly used by for the threat actors when they want to bypass detections of the endpoints. Sometimes you can also find like a high entropy obfuscation, and also in legitimate files which are protected with software protector packers. Again, with the purposes of just anti-reversing, it's all about like copyright and uh, code protection. But let's say if you write a rule based on several logics, right? Okay, give me everything which has the entropy equal or higher to 7. That immediately says, oh, the file is packed, obfuscated. And let's say, and you can combine, and the timestamp of the file is like last 7 days, right? Or the timestamp is it has like a futuristic future date. So you can combine those logics. And then that is how you can also start hunting for interesting samples. Of course, this is not like all these scenarios you may use. You can hunt for many things like, uh, if the file has a domain, third level domain, like we saw in the previous example, like DDNS, uh, okay, it's a Amber Alert, like what's going on? It's like a C2. You can think about other scenarios as well, like I don't know, like a strange header or non-standard sections in the file. All of that will raise your like awareness, and you can go and collect those files and to start digging. Like, is it a legitimate file, but probably like just a bad practice on when coding or not? Same, okay. The file has I don't know, like metadata. It's the file belongs to Microsoft, but it's not really signed by Microsoft. Or the signature is invalid. So the sky is the limit, and it's not only about strings. You see, on all those samples, we haven't seen any any of those rules are actually string based.
I love that because typically when we think about YARA, it's like you see all the YARA rules and it's like, look for these strings, look for that, right? This mutex or this. Okay, great. But what you show there, like even if the PE, is all obfuscated, you cannot really look at, you're looking at the characteristics of the file and things in the PE header, which it's interesting because I was thinking, what if we could combine the power of YARA and Jupyter notebooks? So, for example, we use the PE libraries in Python. We analyze a set of PEs, look at the headers, look at the features and the characteristics of these binaries, and then on the fly create some code that creates a YARA rule that we can use for hunting, right?
Absolutely. Yes. So that was like an idea for those who are here also, like if you want to like to build new products, yeah, you can do it. If you make it open source, it will be
Let's
very much appreciated.
let's do this. If people actually have interest in seeing something like that, maybe we can do that in one of the next LinkedIn lives. Uh,
Yeah, why not?
so if you're
And
interested in that, let us know in the comments so we can work on that.
yes.
Okay,
Yeah,
cool.
and we have comments here, code-based Yara research. Yeah, it's great. It's real deal, absolutely. And what is good also with Yara, you can see you can provide those rules to the community. So if you found that your rule is effective, why not to share it? Just share it. Use your GitHub. Or there are projects like YARAFI. It's maintained by Abuse from Switzerland, and you sign up. You provide your rule, and you can start also helping to hunt for those new files, and also you get notifications, right, when your rule matches the file which is submitted. So basically you get the sample. So that is also another win for the community.
I love that, and that's a very simple website to use, right? You can just like start using Yara right away without having to install anything on your computer. Now, we've been talking about this for 40 minutes. It looks like maybe we love this topic, right? And we could talk for hours about this. But since you talked about sharing, I want to let the audience know that this team, the threat research and intelligence team at BlackBerry, we have a GitHub where we put a lot of these IOCs that we report and YARA rules, right? We put a lot of YARA rules in there that we report as part of our Threat Thursdays, the blogs that we publish on a regular basis. And, many times at this space in the LinkedIn Lives, we cover some of those blogs. We talked about Monty recently. Sometimes we talk about, other topics of interest in the community. Sometimes we, do interviews, or if you actually like this type of format where we can go a little bit more educational and invite some of the members of the team to share what we do and how we do it. If you guys like it, let us know. Share your comments, and we'll be happy to do more of these teaching sessions. What do you think, Dima?
I love it. Yeah, when we thought about this session, I just said like, wow, we need to do that. It will be, and we hope you also like it, and we will be happy also to continue providing this um, high quality content.
Excellent. All right. Well, if you don't have anything else, Dimitri, why don't we just say goodbye, and we'll see you in the next LinkedIn Live.
Yes, thank you, Ismael, and also thank you everyone who attended this webinar. And as we say in Spanish, ciao, ciao,
Ciao.
ciao.